Hello, welcome to our webinar. Good morning, good afternoon, good evening, whatever time zone you are in. Welcome again to our MLflow 3.12 webinar for this month. My name is Jules Damji. I'm going to be your host. We're coming live from you on 3 different channels, X, YouTube, as well as LinkedIn. And joining me today are your familiar faces from the MLflow maintainers. We got Yuki all the way from Tokyo. Hello, Yuki, you want to say hello to the community? You're the familiar face and a familiar voice, so everybody knows you. And anybody who's coming here for the first time, Yuki is a common voice on this particular webinar. And then we got Tomo all the way from Japan as well, and he's been giving us a lot of information about Guardrails, so you're going to hear from him. And then we have a new face today, Chris Concepcion, who is a maintainer, and you're going to hear from him today. So thank you for coming, and let me just give you a quick agenda of what the happening today. As I said, we have some welcoming remarks, and we have some upcoming events that I wanted to share with the community. So those of you who are in the vicinity, or if you're in the Bay Area, or if you're somewhere where these events are happening, I highly urge you to attend those, because it's going to be something that you will benefit quite a bit. And then we're going to go into the technical deep dive from some of the features that are coming up in 3.12, coding agent and tracing by an OpenClaw. UK is going to share that by giving us a deep dive into that. And then we're going to find out how you can actually evaluate your and test your and refine your coding skills. And everybody these days is just writing skills like left and right. So this would be sort of a good education to figure that out. And then we have a new feature that people have been waiting for the longest time to have multimodal attachment support that Chris is going to share with you. And then we have our final gatekeeper, Tomu, who's going to tell us all about how you can actually keep all the bad things away from your LLM request. And then I'll ask you to reserve your questions towards the end, because the nature of this particular platform, we can only broadcast, we can't hear you. So put your questions in the chat. If you are coming in live from any of the YouTube channels, put your question. There's going to be filtered, and I'll have the questions towards the end. So we try to keep the questions towards the end of the last 10 minutes. And having said that, let's just go and to the next slide to see what's some of the events coming up. If you are living in the Bay Area, if you are sort of a stone away where I am in the Bay Area, we actually have a really good event happening tomorrow. It's going to be live in person in San Francisco. So if you are in the Bay Area, do attend this particular meetup. We have a marquee speakers and marquee companies who are going to be talking about coding agents, productivity, accountability, how you actually govern some of the agents. You might get a glimpse of governance today from Tomu, but this is actually going to be a good parallel sessions of people from Anthropic, OpenAI, One Password, who are very familiar with security, and people from Factory who's going to be giving a talk. So if you're in the Bay Area, register and do join us. Next slide, please. Now, this is a marquee event. We have this event once a year. It's really like a pilgrimage to come to this. We have about expecting 20 or 30,000 people, maybe more than that, descending down to the Bay Area. This is going to be Data Plus AI Summit. We have talks from all the open source projects, including MLflow. So if you're coming down to the Bay Area, make sure that we actually connect. So this is a huge event. You can register right now at Data Plus AI Summit URL. This is a good event, so hope to see you that. And you can also join virtually. There are different grades and different tiers you can actually join. And then finally, we actually have a world tour of this Dev Connect that are happening virtual shows. We have done half of them in this part of the world. We actually did 2 yesterday in Europe, in London and Munich. And we're going to start kicking off sometime in August in Montreal and Sao Paulo and Vienna. So if it's coming down to your city, next to your city, do join us, register at that particular Dev event. We normally have 2 to 3 talks. We talk about MLflow, we talk about agent bricks, we talk about Neon, we talk about agents, anything that agent developers are working, they're concerned about, you will actually hear that in this technical deep dive. So hopefully you can attend those things. And then finally, we do want to hear from you because the community is central to the success of any open source project. And I don't hate to say that, this is actually a known fact. And there are various ways you can actually participate in this community. You can join us on Slack. We have an active Slack channel with about 6,000 people. So you want to keep up to date. You want to ask any questions, you can join us on Slack. You can also follow us on LinkedIn page where we post regular blogs, regular announcements, regular events that are amenable and applicable to MLflow. So do join us and do follow us, as well as you can follow us on Twitter. And if you are on Luma to find out when is the next event coming up in your Bay Area, or when is the next event coming in the part of the city where you are, Luma.mflow is the way to go. Okay, having said that, I really want to get in the meat of the matter. I'm going to hand it off now to Yuki, who's going to deep dive into a couple of topics that he feels really endearingly close to. And so hopefully we can actually get some good insights into that. So Yuki, take it away. And I'm going to mute myself and disappear for a while.
Sure. Yeah. Hi, everyone. Hi. Good morning, good evening, good afternoon. I'm Yuki. I'm a tech lead in the OSS like MLflow team right now. And yeah, probably hi again for many people who are following MLflow events so far. And today I'm going to talk about, oh, wait, is the slide is on?
Probably not.
Okay. I'll share that then.
Yeah, you have to share it because I think we're having difficulty uploading the slides.
Understood. Okay. Yep. So today I'm going to talk about tracing for coding agent. So I know everyone loves coding agent. I love coding agent. I use it heavily in day-to-day work. But yeah, sometimes it feels like coding agent is a black box, right? So we chatted within terminal and ask it to do a lot of tasks and codings, but sometimes it start to get dumped after an hour. I talk with it. It start to do like compaction, and after the compaction, everything becomes like different. Also, like if I ask just hey, please change this to line, and it start to consume like thousands of tokens because it's trying to do like a lot of testing or unnecessary validation, or maybe some leads to too much reasoning. And also, if I install like skills or tools or things, I want to know like if the coding agent actually use it or not. And all of these are kind of, we can see if we monitor the CLI or monitor the chat terminal. But after that, like if, for example, if I remember the conversation I did with coding agent for 1 week before, probably not. So I wanted to get some more visibility into the coding agent. The answer is tracing. So yeah, we've been talking about tracing for quite a few times in this talk, so you're probably already familiar with that. But tracing in a nutshell is a kind of structured log that capture everything that the agent does. So LLM calls, which prompt, what messages are passed to the agent, what tools are given to the agent, what tools are executed, and token counts, latencies, and some metadata like session grouping. All of them is in a single object called trace. And in the MLflow UI like this, you can actually see the hierarchy of those, like each step coding agent does. And yeah, so you can see that, for example, in this case, this is a trace from Claude code. So you can see the Claude code invoke sub-agent invoke LLM a few times, and bash tools read the code read tools and to get the task I given to the coding agent, which is a summarizing this coding this repo. So yeah, tracing is so this screen is for Claude code. And if you followed MLflow for a while, you already know like, hey, yeah, MLflow supports Claude tracing for trace like in a half year or something. So like, what's new? Then the news here for in 3.12 is we support much more more coding agent libraries. So not only Claude Code, now we support Codex from OpenAI, Gemini CLI from Google, and OpenClaw, which is probably the most favorite like open coding agent, and QN Code, and also OpenHands. So in 3.12, we bring integration, built-in integration for tracing for those coding tools, not only Claude Code. And in addition to that, we also did several enhancement for the tracing itself. So first one is sub-agent support. So sub-agent is a pretty popular like method what that coding agent use to optimize the context usage. And now you can see what actually sub-agent does, not only the main agent you are interacting with. And for the token usage, we shipped the cache token handling. So generally, the LLMs like have a prompt cache feature. So when you ask the same question again, it uses a cache token. If your question overlapped a lot with the previous question in the prefix, then it uses a lot of cache to optimize the cost. So now coding agent trace also has a cache token, this cache token breakdown, so you can inspect the cost more accurately. And lastly, the agent graph UI is something we shipped pretty recently. So if you use Claude code tracing once, you realize that there's a lot of steps. So it loops the LLM code and tools like bash tool, read tool, edit tool, and it's very easy to get like 100 spans in a single trace, even for like single conversation. So like debugging those big traces is hard. So we shipped a feature called Agent Graph UI, which can consolidate those low-level spans into conceptual node following the agent structure. So for example, in this case, we have a Claude code main agent in here, which use the tool to run sub-agent, which spawn up sub-agent here, and sub-agent using an LLM and bash tools and lead tool to do its job. And each tool has like 40 spans, but everything is consolidated here, so you can see the overall structure of the agent without manually analyzing the row span structure. So this is pretty convenient for inspecting the traces from coding agent. And in addition to those enhancements, we have a like session view as well. So every coding agent integration, the codex, current code, open code is supposed the session view. So within your conversation, if you interact with the coding agent multiple times, you can see the summary of the conversation from here in the session view. And of course, we have a dashboard for traces, so it applies to coding agent as well. So you can see that tool usage across different coding agent, which tools is taking more time, which tool is failing, which tool is more used by your like maybe teammates. So you can inspect you can get a lot of information distilled from raw traces in the built-in dashboard. And to get started, it's very simple to start. So first step is spin up the MLflow server. MLflow server. So run the MLflow server command, and you get the like server running in localhost, and then enable tracing. And most of the integration we ship is based on npm package. A lot of coding agent is built in TypeScript, like node-based app. So we ship the npm packages to easily install MLflow hook into your agent. But some of them are using OpenTelemetry, like Gemini CLI. In that case, you don't need to install npm package, but each package has some simple setup structure. So you can go to the doc or README of npm to set up tracing. And then once tracing is on, you can completely forget about that. So you just run coding agent as usual, and all the traces flow into MLflow server, and you can go to the UI to inspect or monitor the usage. So pretty simple. And yeah, so now you get the traces, and which leads to my next topic is how you improve your coding agent with those traces. So getting traces is fun. Like you can see what's happening under the hood of coding agent, and also monitoring the usage is also important. You can see which tools you use, which skills you use from the dashboard. But the most important thing is how to use those information right. And one effective way to improve coding agent, so improve how coding agent do the task, improve how they produce artifacts, is the agent skills. And in this second section, I'm gonna give us some talk about how we use this tracing and some evaluation feature in MLflow to improve our agent skills, which we actually ship in the production, ship in the users. So I'm not sure if you're aware of this or not, but we built skills for MLflow. So this MLflow skills is a MLflow/skills repository, contains a lot of skills that allows agent interact with MLflow very effectively. For example, instrumenting traces, running evals, getting result from the server, editing prompt. All of those like operation requires some sort of specific like REST API and setup. So this skill tells agent how to do those things properly and with less tokens. And we ship this skill, but The problem is we need to know they actually work, right? So we were shipping the skills to the lot, like thousands of millions of users in MLflow. So we don't want to ship something very broken. But knowing skill actually working is kind of challenging. For example, there's a discovery problem. So even if the skill itself is correct, if the coding agent doesn't discover the skill while running task, it's a failure. Also, even if the skill works correctly at one time, since MLflow product is evolving very quick and API and CLI signature sometimes changes, the skill also need to be up to date to all of code base change. And we could test manually. Like most of the time, we test like skills manually in our like day-to-day. Like for example, custom my skill, I just test manually first. But when it comes to like actual production level like this, we need to have a automation. Otherwise, it takes too much time to check it every month. And the solution we built is a test harness for skills. It's like a software development cycle, but focusing on skill. So the first step, we run the agent with skill. So we do this by headlessly. So we don't interactively run the CLI, but rather using Claude -p to run the skill automatically, add tracing to see what the execution looks like, and give it to the judge, so LLM judge or rule-based evaluation criteria to see what's going well and what went bad, get the rationale on the result. So all the LLM judge and scorer returns why this fails. And then we pass it to the Claude code back. Then Claude code automatically make the edit until the test case, basically until the judge pass. And then we iterate on this like a few times, just like a lot of loop for software. Then finally, we get a good quality of skill. All the test passes, all the judge passes. So this is pretty effective structure we found. And how we build this harness is, as I said, there's a few important aspects. So as I said, first, it needs to be headless, because if we have like human intervention within this loop, it becomes bottleneck. So it needs to be automated. And also the tracing plays a very important role. Like the outcome of the skill is not necessarily very easy to evaluate. For example, it might change the environment, like install some libraries. So instead of like inspecting that outcome itself, we can look at traces and what happened during the execution. Then we can easily spot, okay, so this library is installed, or like this code is edited. So that is tracing is a very important aspect of how to evaluate skill. And also we build so as I said, we build a judge, and we use a hybrid of rule-based judge and LLM judge. And yeah, and then with this combination of like test harness and headless mode and LLM judge, what we get eventually is that like skill prompt environment, those like set will produce a very reproducible like result. So now we can rely on that to test our skills like reliability or performance. And then speaking about judge, so what is a rule-based and what is LLM judge? So LLM judge is basically evaluating the trace using LLM. The rule-based judge is evaluating the trace or maybe outcome using the heuristic. And both have the pros and cons. For example, in the left side, LLM judge is checking whether the application is executed by agent after adding traces. And doing this with rule-based is pretty tricky, because one way is like parsing traces, finding other steps where agent runs the application, but the command might not be always same. It might have some sort of environment variable setting. It might like use some sort of script. So instead of rule-based, instead of exact match those like steps, we can ask LLM to say, hey, please analyze trace and find a step. On the other hand, LLM judge is expensive. So if we can do things by rule-based, it's always good to do that without LLM. So in the right side, what we check is a dataset, whether the dataset is created or not. This is pretty simple. Like we can just search the backend and find the dataset. So we use this, we built this as a heuristic judge. And then good thing in MLflow is that both LM judge and rule-based judge share the same interface. So once we define the judge here, so agent run instrumented code or dataset created, you can run it in the same interface. So you don't need to like set up different things. So with this allows us to like switch between rule-based and LM judge by needs, or flexibly express the evaluation criteria without worrying too much about implementation. Another important thing for we found is composing the evaluation criteria as simple as possible. So one way to define the judge is like, hey, this agent completes the task. This is pretty high level in general, and it requires domain knowledge. And it's always like, so that's kind of like high level judge always has a risk of like being very unstable, not very consistent on the judge criteria. So instead of having such kind of big judge, we recommend creating a small judge. So decomposing that success criteria into different aspects. Very simple, atomic aspect, like dataset created, score is registered, evaluation run is added. And then if we compose this criteria, another nice thing is if the coding agent runs the eval and get the result, it gets very granular signals about what went bad. So it can fix the issue, the direct issue, rather than trying to inspect what went bad from the task. And then now once we set up the task, so yeah, we can run the route through for skills. So run the coding agent run the test suite itself, sees a rationale from the judge, and apply back to the Claude code. So apply it back to the skill. So it's just like a simple while loop where agent runs test a task and then test and fix. That loop is this works pretty well for skill as well, because it works for code, and skill is much better, much simpler in terms of its format. So as long as we have the good harness, which is a good test infra, we can let coding agent automatically improve the skill without human intervention. And yeah, here's some concrete example of the fixes we made. For example, this is a case where we ask coding agent to, so if we ask coding agent to do please evaluate this with MLflow, it does use MLflow. But if we just ask coding agent saying, please do tracing or please do eval, it attempts to build their own solution rather than using MLflow. So in this case, the judge is datasets created, everyone created will fail. So Claude coding agent automatically understand, okay, so we need to update the skill to explicitly mention MLflow framework. Another fix is dependency management. So not management, dependency between skills. So the best practice for skill building is trying to make it a modular, right? So instead of having a giant skill which lists everything, usually it's better to have a atomic skill for each at least for each task, and then let agent discover the different skills for their bigger task. But the challenge is that sometimes there's a dependency between tasks. So for example, if we want to evaluate something, we first want to make sure the trace is there. So in that case, if we have two skills of evaluation skill and tracing skill, we want to make sure tracing skill is also loaded before evaluation. So this is one of the failure mode which we discovered from traces. So the some of the judge is detect this from trace. It's very hard to do without trace, right? Because in the outcome, it doesn't say which skill is installed, which skill is loaded, and which skill is in which order skills are loaded. And then as a result, the agent made a very simple fix. It just say hey, important, please load this skill before using this skill. But yeah, this works pretty effectively. And since we have traces, we can automatically detect that without reviewing skills manually and instruct agent to do this fix. Cool. So as a summary, what we learned is there's a few important steps, important kind of principle we need to keep in mind when building skills, reliable skills. First is write judge first. So in order to build this automated framework, we need to define very good judge criteria. So we need to think about what is success criteria and decompose it into atomic evaluation criteria. Another thing with trace is actually pretty important because the outcome of the coding agent, outcome of the task is often very abstract. And also there's a lot of side effects that coding agent can do. So in order to evaluate, in order to assess all of these details, we need to have tracing. And tracing gives a lot of rich information about what coding agent did at each step. And third, we have some learning about judges. So yeah, LLM judges good, rule-based judges are good, but both are necessary. We cannot really complete a job without only from one. So it's important to make sure we have a flexibility to pick the implementation, and we have a good sense of like, hey, this needs to be done by LLM judge, or this can be done rule-based. And finally, another interesting point was so relational from the judge is actually pretty important. So since we built that Ralph loop, after the testing, what we want to make it happen is a coding agent fixing the root cause. But if the judge doesn't tell why it failed, it's very hard for coding agent to take action. And most of the LLM judge in general, in any framework, returns rational. But it's very easy to forget about that for rule-based judge we build custom. So if we define a function of the rule-based judge, it's always like, hey, we return the true or false. But most of the case, we don't try to write detailed rational in the result. But yeah, it turns out it is very important to make sure the rational is also returned from rule-based judge so that the coding agent can take action based on that. Yep. So yeah, that is it about my section, and hopefully this experience of we build skill also helps you to gives you some insight about how to build skills and how to kind of build harness around your coding agent to write the skill of their own. And yeah, we'll be putting more features into coding agent, and we will have more integration soon. So please please tune in it, and I just pass it to Chris for the next section, which is multimodal tracing.
Well, thank you, Yuki. Thank you very much. And those of you who actually want to try these skills out, please go ahead and do that, and let us know. Give us any feedback on the MLflow issues. We have Chris now, who's going to take over and tell us all about multimodal attachment. Take it away, Chris.
Hi. Yes, I'm Chris. I'm a software engineer on the MLflow team here at Databricks, and I'm going to be talking about multimodal attachments in tracing. This is a new feature that is landed in 3.12, and it fills a gap that's gotten more and more painful as users have moved from text-only LLMs to using multimodal apps. Share. Great. So yeah, before 3.12, debugging a multimodal AI app in MLflow looked kind of like this. And so you'd click on a trace, you'd open the span. This span would be for a vision model, and you would be greeted by a truncated 50,000 character base 64 string on your input panel, which is what the underlying representation of the image would look like, but is not terribly helpful to you, the end user, in figuring out what was going on in this particular span. The UI cuts it off. Also like it's not even the full bytes, the full set of bytes. The UI cuts it off, and you get a see more button here. And if you click the see more button, you would just get more bytes. So yeah, this is not great. And the reason for this is relatively straightforward. Again, AI applications have gone, more and more multimodal over just the last year, right? You have vision models analyzing photos, audio APIs are, transcribing calls. You have agents that are generating images, rendered documents that are being processed, audio being returned. The bytes that you've been dealing with these LLMs have just changed. But unfortunately, the MLflow tracing had not. It was text-based only, And so that's the paper cut that you're seeing here, is that we're not rendering these things properly for you. So what this would mean is that every image input to a vision model, every audio output from a speech model, any generated image, every PDF, etc., all of this would land in your trace JSON as a giant base64 string. And those strings are not small. A single image, can be multiple megabytes of these strings. And then, that would expand to, thousands of traces. You can end up with gigabytes of binary data sitting in your tracking database, which is absolutely the wrong place for where you would want this. And so you ended up with like three very concrete problems with this. The first is that obviously your trace database starts to bloat really fast. The second is search would slow down, right? Because you have all of this binary data. The ability to search traces would just, a list operation would end up having to pull in many multi-megabyte payloads. The UI would lag. It just became very painful to do search as you had more and more of this data. And then finally, third, obviously, the practical instance of when something goes wrong, like you don't get to see what actually went, what actually happened here. Was the image actually misclassified? You don't know, because you have this byte string. You would actually take a bunch of steps to convert that into something that you could use. So yeah, that's where we were. But let's talk about what we've moved to. And so the approach to fixing this is relatively straightforward. It's three steps. It's extract, store, and render. The extract portion here, when a span's input or outputs are set, MLflow will now scan for binary content. The data URIs, audio blocks, base64 image output, Anthropic blocks, Gemini inline data, Bedrock images, etc. We recognize all of these patterns automatically. Whatever provider you're using, the binary data just gets pulled out of the JSON. But then where does it go? So that's the store part of this. The extracted content goes into your artifact store. And this is the important part. We don't actually ask you to change anything. We use the existing artifact store that you've already set up. So S3, Azure Blob, GCS, your local file system. That's where these multimodal trace attachments are actually going to live now. So it's the same storage, same credentials, same retention policy. It's being used for the multimodal data, and as opposed to your database being used for the multimodal data. What stays in the span itself is just a lightweight reference URI. It's only about 120 characters, which is a pretty big difference from the megabytes of data that was being stored into your database. Your database will continue to remain small, grow a little bit at a time with each new trace, as opposed to a lot at a time if you have a lot of multimodal data. And the actual attachments go into a backend that's geared for storage of blobs, as opposed to like a database that is not. And then finally, the render. So the UI now fetches the binary data on demand when you open a trace. So you don't have to pay any rendering cost at the trace list view. It's only when you click into a specific trace will the UI then attempt to render the data in question. And again, the things I want to highlight here is there's no new infrastructure. You just reuse what you already have. We're just using it in a better way now. So if you're already using MLflow auto tracing integrations, you don't have to change anything. All you have to do is upgrade to 3.12 and redeploy. And then the next time you run, you should start seeing this. And what you should see, that this is what you'll end up seeing now. So in the UI, this is the same trace from before, but this time you see the image is rendered in line along with your text prompt. The response is underneath. Unfortunately, in the screenshot, I didn't actually expand it, but it's there. So yeah, you can see the cable car. You can see the prompt that was asked. if you expand, you would be able to see the actual response from the model. You don't have this giant base 64 string staring you in the face. You're able to make a quick judgment about this trace, as needed. Yeah, so if you clicked on this image, it would expand into a full screen preview. For audio, an audio built-in player would play the audio that was included in the trace. If it was a PDF, we have a PDF renderer that would embed the actual file so you could view it. And it's not just the chat tab, right? It's the rendering happens in summary view, details panel, the timeline. Anywhere that a span shows up in the UI, the attachments now render. And again, you didn't have to write any additional code to get this. It's all just happens with with this new version of MLflow. And so what actually, again, like I mentioned before, what happens to the data? So before you had the megabytes of data, and now it's just been replaced with this lightweight URI. So if you clicked on the JSON viewer here, you can actually see the reference. And again, the difference is dramatic. It'll be dramatic in your database size. This is just it's a pointer to a blob as opposed to the blob itself. So your database will stop loading. Your trace search will remain fast. And the heavy content is where it actually belongs in your object storage. So why does it matter? Again, as I alluded to early on, the nature of these models have changed, right? You have vision agents, you have voice assistants, you have document processing workflows now. For a vision agent, your agent looks at a photo and it gets a classification wrong. If you were trying to debug that, you would have to take a bunch of steps to try to get that base 64 string out of the trace viewer and into a separate viewer that would be able to render the image for you, so that you could then do this triage. But now you actually see the image, and it's right next. It's right next to the model's wrong answer, and you would be able to tell right away whether the model misread the image or whether the user uploaded something ambiguous, or it could just be a pre-processing bug. But that judgment happens much faster now. For the voice assistants, your audio transcription comes back garbled. Before, again, you'd have to convert that giant string into audio that you could listen to verify whether or not the audio itself was clear or not, or whether the model screwed up, or whether there was some other issue with the file format or anything along those lines. The player's right there in the trace, and so you hit play and you hear what the model heard, and so you'll know very quickly where the source of the error was. For document processing, your PDF summarizer hallucinates an answer, and you would have to once again take the bytes, get it rendered as a PDF, figure out if the source data itself was correct, or if there was a bug in pre-processing, or if the wrong document had been uploaded altogether. The common thread here is just debugging these apps now requires less work and toil. This all just lives in line now. And everything that you need is now in the trace. So our coverage is broad. We land 8 different patterns in 3.12. They cover most of the providers that you're using. We have OpenAI, which handles all of the various flavors of OpenAI responses, including image generation calls, input file content, etc. We deal with Anthropic's native image blocks. They're recognized and normalized to our standard schema. Bedrock's image format is handled. Gemini's inline data pattern is handled. LangChain is supported. LangChain is just a wrapper around underlying providers, but that is also supported here. On the content type side, images are the most common, and we handle all the standard formats: PNG, JPEG, data URIs that the providers use. Audio is supported both for input and generated output. PDFs are handled, and as are arbitrary binary files. And anything that we don't have a specific renderer for falls back to a download link that you can always retrieve the original bytes for easily. The point here is this isn't a feature you have to learn how to use. If you're using autolog or tracing in general, it should all be very intuitive to you now to be able to leverage all of this. The traces just have the right shape for what you're trying to do now. And additionally, I guess I should mention that if you aren't using autolog, there is a new attachment class that you can use. All of this is documented in the docs for 3.12. Again, so I hope that this solves a paper cut that a lot of people have been experiencing, as they have, started to leverage, more and more of the advanced capabilities of these models. It's certainly a paper cut that I've run into, and I'm very happy that this feature is in there now. And so with that, I'll hand it back to Jules.
Well, thank you, Chris. I think this was a feature that people have been waiting to. I was talking about this at a conference the other day, and I told them we've just landed the multimodal attachment, and they go, so it was about time. And I like the way that you actually pointed out the imperative, the key takeaway is that if you're actually already doing auto logging, you don't have to write any additional code. It just appears there in the summary as a URI to the location, as well as when you click on a particular trace, it renders, fetches, and renders that for you. So I think this is a huge, huge win. With that said, I think when I have our last speaker, Tomu, to talk about the gateway, which I think a lot of people are really excited about, how we can actually prevent bad things happening to your agents, or agents behaving in a bad way, or the LLMs behaving in a bad way. So tell us all about this incredible feature we have called Guardrails. The name suggests very vividly what you're gonna tell us.
Yeah, sure. Hi everyone. I'm Tom. I'm also a software engineer at Databricks, working for the OSS MLflow. Today I'm going to talk about the Guardrail feature for AI gateway of MLflow. So, as always, let me start with the motivation. So why you need gateway guardrails? So first of all, especially for the large organization or enterprises, we care about PII, or we care about providing the harmful information from the AI products that you built. So in production environment, there's a trust gap if you provide the AI, Gen AI product. So a language model can leak PII, or might produce a harmful content, or maybe like your company might have a dedicated policy in terms of what kind of content can be provided by your product. Then the typical solution is providing the policies or filters in the application level. But this approach doesn't scale well, because with the increased complexity of the Gen AI application or agent, there are a lot of language model codes, and it's very difficult to apply the same type of policies and filters for all the language model invocation inside your application. So you might miss, there might be always a bug to skip these kind of policies or filters if you have the logic in the application code. Instead, if you have the guardrails or this kind of policies inside your AI gateway, then you can enforce these policies in the centralized place, and you can always provide, apply these policies in a consistent way. So that's why you need the AI gateway guardrail rather than the guardrail inside your AI application. Again, to recap the MLflow AI Gateway, MLflow AI Gateway is a product that you can use to invoke language model, but with an enhanced features such as permission control, rate limiting. This is a new feature, input and output guardrails. You can also get a usage dashboard, which is built on top of MLflow tracing. you can also evaluate the quality of the language model invocation by using the traces, and you can get a unified interface regardless of what kind of provider you are using. So you can use the same endpoint for OpenAI, Anthropic, and Gemini. Let me explain how the Guardrail works. So there's two stages for the Guardrail execution. One stage is before the LM invocation, and another stage is after the LM invocation. Before you can use the Guardrail. You can execute the Guardrail before the invocation if you want to check the PI leakage, and if you you can run Guardrails after the LM invocation if you want to validate the output from the language model, or if you want to avoid generating the harmful information to users. There's two type of actions for Guardrails. One is blocking the request, and another type is sanitizing the request. So you can choose. This action is executed when we apply the policy, and the policy part says this request and response is not aligned with the policy that you have. So there's like a two-step approaches. First part is just checking the request or response based on the policy. Then if the policy is violated, then the action part is applied. Then again, the action is either blocking or sanitizing. For the new feature of MLflow, we support the LM-based validation. So for the validation part, we use LM language model to judge the request or response based on the policies, and we're developing the rule-based validation for the faster and the cheap validation logic. Unlike other AI guardrail product, we allow the modification of the guardrails. So because different AI application have a different use case and the policies, and it's very hard to cover all the use cases with a static guardrail approaches. So we provide the built-in guardrails. We provide the built-in guardrails for PI detection and also safe content detection, but still we allow you to modify the instruction as a natural language with template variables, so that you can tune your prompt for your use case or for the domain that you are working on. And let me do the live demo. Let me switch to this tab. And I think you can see it now. So, okay. First of all, you have to come to this gateway tab, AI gateway tab of MLflow. Then you select your endpoint. Then this is a new tab, Guardrails. So here, I don't have any guardrails set yet. So I will create guardrails. You can select one of the guardrail type, which can be safety and PI detection, or you can just write your prompt from scratch. Then for this demo, I will use PI detection. I will select before LM guardrail rather than the after LM, because this is a PI detection guardrail. Here's a predefined instruction, but you can modify it if you want. Then I will use OpenAI model for the demonstration, but in reality, you might want to use a local model so that you don't expose the PII. Then for actions, I can choose either sanitize or block. For now, I will use block. Okay, I set the guardrail. So let me test this functionality. I open this modal to invoke the endpoint. I will type my phone number. I mean, this is not my phone number, but yeah, I'm just typing now. Then I will send the request. Then this request is blocked because, as mentioned in this response, there's a violation for the PI detection guardrail, so this request is blocked. you get 400. So for your AI application or agent, you can handle this request and maybe try to remove the PI information and try again. Okay, that's all for my demonstration. Thank you, everyone.
Well, thank you, Tomu. Why don't we just go to the Q&A? So I want all the presenters to be on camera so I can direct the questions to everyone. Well, thank you all for your beautiful and wonderful presentation. Very insightful. A lot of great features that we actually been waiting, and the community can now start using it. I have loads of questions, but I think I'll defer my questions and I'll just DM you guys about those questions. But I want to get to the audience right away. The question from our regular attender, Ravi Singh. He's asking, this probably for you, UK. Will the coding agent trace include MCP client calls? Given that you could be, you could be using the MCP calls and all the functions available for that. So you would.
Yeah, it should include basically all the tool calls are included, and MCP should be the one. Actually for Claude, yes. For coding Codex, Gemini, I think the most accurate answer is actually get out by yourself. But I think as far as the MCP is represented as normal tool call, yes, it will be included.
Yeah. One thing I wasn't clear when you were actually presenting about coding agents and how do you actually trace those agents. Did they actually use our standard API using MLflow the coding agent name .autolog, or is it something when they launch from the command line they have to provide that you're going to be doing the tracing? How did they actually initiate and trigger the tracing? Which is unlike if you're using programmatically. Over here, you're using from the from an IDE. Could you talk and explain the difference between the two?
Sure. Yeah, that's a great question. So how we do tracing for coding agent is mostly using hooks. So most of the coding agents have a mechanism hook mechanism, which is a kind of any script that runs after every conversation, every turn, and then every turn or sometimes every steps, or depending on the coding agent. So for Claude Code, Codex, we have a custom hook, TypeScript-based hook, which invokes MLflow endpoint, and to create the spans based on the steps they execute. And some of the some of the library, like Gemini CLI, OpenHand, are using has a native OpenTelemetry trace already. So for those libraries, we just need to set up environment variable. We don't need to insert any hooks. But yeah, in either way, the important thing is that you just set up once, and it is within the terminal. You don't need to do anything.
So the hooks actually is part of our implementation, our integration. So when I say I'm using, Code DMI, we'll have the hooks loaded in, and then when they actually issue a particular request, we intercept the request and then take the trace and then log it in. Ruben, I like that.
Exactly.
Yeah. Okay. All right. So they don't have to actually write the hooks. We provide that. That's part of our integration. That's what you actually meant by supporting it. Another question, probably Chris, this is for you. I think this is for me rather than I didn't see it. I do like the idea that you can actually on demand show what the image actually looks like or what the rendering is. Is there an option where you say, I don't want you to show me the entire video. I don't want to show it until I press a particular button. Right now, I think by default, if you click on a trace, we go to the store and we render it right away. Is that something that we should consider by doing that, or is that by default right now we'll go and render it?
So for images, for sure, it will just automatically render. We don't have the ability to click the button to show it. Something we can certainly look into adding if there was high demand for it. For audio, you actually have to take the action to click the audio player button, so it's not going to play by automatically.
So for certain content types, it will play automatically. At other times, it will delay. Okay. There's a question from Ravi saying, "Are there any plans, Chris, to add additional providers?" Ravi, did you have any particular provider in mind, or do we actually have a list of providers that we might be considering about adding that in the coming features or in the coming releases?
I don't know that we have any new providers in mind. Like if there are suggestions, I would advise the community to add an issue for it, and let us know. And like if there's a lot of demand for it, then obviously we can prioritize getting that in there.
Yeah.
Like we tried to we tried to tackle the most used formats initially here with this first release.
Right. Yeah, the common one. So Ravi, I mean, there you got. If you have a particular esoteric provider that you actually want Chris to support it, please do file an issue, and we'll be more than happy to evaluate and consider that. Another question. I think this is a good one. Probably anybody can actually take that, but most likely. Probably for skills. I consider, this is from Ravi, so I consider skills as an artifact of the agent and or harness. Should be tracked as such in Git repo, or should it be part of the prompt registry? Interesting.
Yeah, this is a great question. So as a spoiler, there is a LSC, the proposal to actually track skills in MLflow. And we are discussing how to build it. But yeah, most of the people today actually track skill in Git. And it mostly satisfies the development needs. Like if I just wanted to store the contents for personal, I think Git is good. But yeah, if you are managing skill for teams or like in organization, and if you want to have some sort of like access control or lineage or version control, then that's where MLflow can help. And so yeah, stay tuned. I think we will build some product in the next few releases to manage skill in MLflow. And of course, once we build that, we are definitely welcome to all the feedbacks. And yeah.
So this would be something very similar to prompt registry and model registry, and you would actually now have a skill registry, which can be versioned, which can be tested. One version was the second. Same sort of APIs, same sort of fluent APIs to build a register to load them and all that.
Yeah, it's kind of it's similar in terms that like it has a like entity, it has version, and it's a lineage. The API wise, the loading skill is a little bit different, like literature than the loading models, because you often don't load skills in Python or in TypeScript directly. Sometimes some libraries do, but if you are using coding agent, you don't add Python script to there, right? Instead, you need to run the CLI or some command to install skill. So there's some difference, but yeah, in terms of what MLflow does, it's pretty similar to prompt registry. So.
Tomu, now, given this is the guardrail question, given that MLflow Gateway Guardrails uses LLM judges to either evaluate the particular policy, whether it's PII, whether it's safety content, whether it's anything else, can they be evaluated and tested with MLflow experiments? And this is the question again from Ravi. He asks very insightful questions. He's one of our attendants who always attends this particular webinar. So thanks for that insightful question. If the guardrail detects PII info, does the trace of guardrail? No, this is the follow-up question. But I think Ravi was asking, can the MLflow Gateway guardrails be evaluated and tested with MLflow experiments?
Yeah, great question. For the first question, yes, the answer is yes. So you can. So actually, in the implementation detail, we use MLflow judge as our first part of the guardrail execution. So for the evaluation part, we use MLflow judges. So if you go to the MLflow experiment tab and go to the judge tab, you can actually iterate on the judge prompt. Then you can use the same prompt for guardrails. So you can evaluate your prompt, your guardrail prompt with MLflow.
So in other words, you don't have to write the programmatic evaluation. You can actually use the online judges to add.
Yeah, you can use online judge. You can do offline judge. You can do that. You can run the evaluation based on the functionality of MLflow.
Okay, and then the answer to the previous question was, if the guardrail detects PII info, does the trace of the guardrail react to the PII info?
Right now, we don't deduct the PII info, so you have to be careful about the permission for traces. Traces is under experiment, so you have to, so for the information that can contain PII, you have to set the permission. You have to enable the authentication of MLflow and make sure that only the permitted user can see the traces.
Now, I think one thing that actually I'm thinking about, and also Ravi also sort of mentioned, is this. What's the hard part about multimodal is the guardrails. Can guardrails be used with the multimodal? So, I mean, how do I detect, how would I detect malicious content that I am sending a request?
Yeah, good question. Our guardrail right now is using language model. So if the guardrail model is supporting multimodal, you can actually validate their request or response with language model, even if the request or response includes images or videos. But you may want to iterate on the prompt because multimodal needs a lot of careful instruction.
Right. And this would be part of the safety the safety guardrail.
Yeah, it can be a safety.
Or you would have to write your own custom one.
Yeah, I think probably custom one because MLflow doesn't know what kind of information you care about. So I think it's easier for you to light up.
So for detecting, harmful content, video or picture, you would probably want to write your own custom guardrail and then use the language and the vision models to detect the whatever the prompt is actually suggesting. That would be the strategy you would use.
Yeah, exactly. I mean, you may want to start with built-in safety instruction. Then if it doesn't work well, then you might want to write a prompt from scratch, or maybe modify the safety content prompt to tailor your use case.
Okay. Another question from Ravi. Can DSPI be used to correct or optimize a skill? Because a skill is a type of a context injection. So the skill is kind of, I think he's equating the skill to be a prompt. And so can we actually use the DSPI to improve the skills?
I'm not sure, to be honest. Like DSPI, at least at the moment, the version of DSPI I know didn't do that, but they might have something new. But yeah, like technically, I think in theory, like the optimization should be able to scope skill as well. But I don't know the library itself supports that. Like, yeah.
I think to answer your question, technically yes, you can use DSPI or maybe like a prompt optimization library to optimize your skill, because like a skill itself is a prompt, so you can treat skill prompt as a DSPI prompt, and you can run the optimization. I think the hard part is that you have to define the evaluation metrics. That you have to prepare the data set. That is the hardest part for the prompt optimization. And if you are willing to do that, I think you can use DSPI for optimizing it. But I think you have to do a lot of work for the evaluation part.
So I mean, so when you're actually defining when you're defining the instance of the class get optimizer over there, instead of providing the prompt, you would actually provide the entire skill.
Yeah,
and then you would give the list of all the very rigorous scores that you are saying that you should provide in order to evaluate that. And that's what the optimizer would use to align. Is it going through maximum? Is it going through its budget or early stopping or whatever?
Yeah, I mean, technically you can use ML for judges, but again, I think it's not universal. So you might want to write your Python logic or whatever language logic to run the skill that is provided proposed by DSPI optimizer. Then run the skill with your agent harness, and you have to also consider how you define the good result of the skill and the bad result of the skill. So this kind of evaluation harness need to be written by you. And
okay, I think we are about 10 minutes over time. I'm just going to have one last question. And I think this could be for anyone. Earlier, I think you could probably you mentioned that we actually do cache prompts, right? In the new version, we actually cache the prompts. And so if somebody actually has the same prompt, then we don't have to actually, we can save the tokens that way. Does the cache prompt have to be identical to the new prompt, or it has to be semantically identical?
Oh, okay. So first of all, who do the cache is not us, but the LLM provider. So Anthropic, OpenAI, they do the cache. And what we do is showing whether the prompt is cached or not in the trace. And how the cache works, it's probably there are different ways. Like, for example, some people do the semantic cache still, but most of the popular provider like Anthropic, it's just a prefix match usually. So they just like match the tokens from the start. And if it's exactly matched, then it use that cache. And so yeah, it's pretty strict and not like fuzzy much. But yeah, it's also like depending on the provider's implementation, and the most popular ones should be the exact prefix as far as I know. Yeah.
Okay, I think with that, Yuki, Tomu, Chris, thank you very much for sharing your knowledge, and thank you very much for sharing with the community all the great features we have in 3.12. Yuki, what does the community anticipate in 3.13?
Yeah, one thing before we wrap up, I forgot to talk about OpenClaw at all. I supposed to talk about that, and I sorry for that. Like I totally missed that part. And so there is a blog that talks about OpenClaw and MLflow just published this morning. So
okay, all right.
if you visit the website, you can see the blog. Also, our LinkedIn, Twitter will announce that blog. So please check out if you're using OpenClaw and you want to do like tracing, monitoring, or those things. That's one. And yeah, then for the next feature, yeah, there are a few features which helps you manage trace better, more efficiently. For example, you can archive traces from the database to trace as S3 or first. Also, there are a few quality of life feature, which is like filtering the spans more effectively using some like log level concept. There's some PyTest integrations. So yeah, a lot of features, but yeah, I don't spoil too much at this moment, and we can speak about those features in the next webinar.
Yeah, and then we do have the roadmap on the website or on the GitHub, so people can actually find out what's actually coming up. With that, I think I want to thank all of you joining us from different parts of the world. I know most of you have joined you from oceans away and lands away, and some of them are just a stone throw away from here. So thank you for all of you joining, and thank you for you all speakers, Chris and Yuki and Tomu, for sharing all the knowledge. With that, we'll say goodbye, and we'll see you in